Hi, my name is Nianyu, and welcome to my presentation on the first out of 3 academic papers for the course Complex 529. This paper talks about reasoning about when to provide explanation for human-involved self-adaptive systems. The authors are Nianyu Li, Javier Cámara, David Garlan, and Bradley Schmerl. This paper was published on August 2020 at the IEEE International Conference on Autonomic Computing and Self-Organizing Systems. To introduce the problem that this paper tries to solve, let me briefly highlight 3 topics that relate to this area. The first one is self-adaption, which is the capability of modifying the structure and behavior at runtime in response to changes in the environment and the system itself. The second one is human involvement, which in many cases can provide expertise and contextual information that are not available to the system, and perform adaptations involving the changes that cannot be automated by the self-adaptive system. The third item is explanation. It is introduced because when human operators cooperating with the system, they may not fully understand the system state and the system goals to carry out their actions. So system-generated explanation can be used as a way to improve human understanding and ability to cooperate with the system. Well, the problem that the paper tries to solve is not lying on any single one of these items, but a combination of them. The key problem is about the balancing on when to use explanations in a human-involved self-adaptive system. Too little explanation, the human may not be as effective because no enough information, but too much explanation, then the system will be slow to respond because explanations come with costs in terms of delayed action because the human will need to read and understand the explanation before carrying out an action. So, how to reason about when to use explanation? Just as the title of this paper is the root problem they try to solve. Deciding whether explanations should be provided is not an easy task, because mainly 2 factors bring additional sources of uncertainty, affecting the behavior of the system. For one, the influence of the explanations on humans can be affected by factors such as the level of expertise in carrying out particular tasks. The other uncertainty is that the cost incurred by the explanation may reduce the satisfaction of system goals. And although the explanation structures and evaluation were investigated before, challenges still exist, like understanding how timely explanation comprehension works, and also understanding its influence on human behaviors. In the paper, there are 3 related areas mentioned that were previously done. The authors carry out this work mainly based on these 3 topics. First one is stochastic multiplayer games. SMG is a probabilistic model checking technique for formally modeling and analyzing systems that exhibit stochastic behavior, allowing quantitative reasoning about probability and reward-based properties. The second topic is human involvement in self-adaptation. This is a picture with human involvement added in the feedback loop. In this new loop, monitor can receive information from humans in the situation that it is difficult for the system to automatically monitor or analyze. Then humans act as sophisticated sensors. They can indicate whether there is an ongoing anomaly based on context information that is not captured by the system. There are also studies for explanation before. Many works in the fields of philosophy, social psychology, and cognitive psychology have studied what constitutes an explanation, how they are structured, as well as how people generate and evaluate explanation. They also distinguished explanation phases, discovered the different explanation types and decision model types. The key idea of the author's approach to enable automated reasoning about explanation is to consider it as one of the possible actions or techniques that the system can enact as part of this adaptation strategy. Such tactics come with associated context-sensitive costs and benefits that affect overall system utility and allow probabilistic planner to determine the optimal use of explanation under an uncertain environment. They included a non-deterministic choice of using such explanation tactics in the SMG model. The probabilistic model checker is then used to analyze the model, produce a strategy that maximizes the expected utility by selecting when explanation should be given. Based on these ideas, they defined a formal framework. Key to this framework is the use of explicit model of human capability and willingness, which are affected positively by explanation, as well as the notion of delays induced by explanation. Using the framework allows an online planner to determine when explanation will be effective. Important features of the framework are that it can be turned as needed, and the system is modeled as a SMG with 3 players to implement the design. So how does this work better than others? First, for existing works, none of them capture the explanation cost or the latency that it induced in adaptation behavior. Second, in this work, they built on SMGs, which is particularly suitable for their purpose. Then, different aspects of explanation is analyzed. Prior works was investigated the role of explanation as a mechanism that human agents are involved in a supervisory role, either approving or rejecting the autonomous system's proposed action. In contrast, the aspect of explanation in this paper is in the context of a human operator carrying out tasks for the system and the cost that incurred. To evaluate their work, the authors apply their approach in a representative scenario for an adaptive website. The incoming load of a website can come from either legitimate clients or DOS attacks. In this situation, the system requires a human operator to accurately identify attackers, eliminate traffic from malicious clients by adding the IP addresses of attackers to a blacklist. They analyze the result in 2 scenarios, eliminating malicious clients and optimizing the experience of legitimate clients. The results show that explanation can enhance the performance of the system when involving human operators, especially when they have intermediate training levels. And the second summary in the result is incurring the cost of explanation is not valuable and can even be detrimental effects when operators are close to the top of their capabilities. And 3, implementation improves system utility across large regions of the state space. The study is rather high level. Besides limitations that was already mentioned in the paper, there are other uncertainties. For example, since comprehension time for explanation is not easy to predict across different operators, how to quantitative estimates of time for the operator to understand the explanation. Besides their willingness and capability, the complexity of the explanation also matters. Any other rules can be added in the uncertainty list. This topic can be discussed to make a stronger argument. Anyway, this paper is more of a bring out topic and suggests a number of additional research directions, topics for further discussion, rather than a practical solution.